This is AP Calculus AB Solutions to Final Number 1. This is the free response part. So as a reminder, the way that I want you girls to work on these problems is to write the correct answer next to the answer that you have to make sure you know how to do each of these correctly. For number 1, we're asking about the speed of the particle. Whenever we're dealing with speed, you need to answer two questions. What is the velocity and what is the acceleration? If they are both the same, then the speed is increasing. If they're a mismatch, one's positive and one's negative, then the speed is decreasing. So we need to use our calculators to find this. So let's pull up our calculators. The quickest way that I did this, let's see if this turns on, come on, is I plugged in both of these equations into my y equals functions, and I did 0.5 instead of 1/2, but it's basically the same thing. So y1 is my velocity, y2 is my acceleration, and then I can just graph it. My window was from 0 to 6 because I noticed that for the rest of the problem that seems to be the interval that we're looking at, and I hit zoom 0 to get these two graphs. It did take quite a while to graph, longer than normal I felt. So from here, you want to plug in, so I'm going to go to trace actually, and I'm going to plug in 5.5 because that's the time that we're looking for, 5.5. And we see with our y1 function, which is velocity, so the velocity of 5.5 is equal to a negative 0.453, negative 0.453, and I also need to find the acceleration at 5.5. So I can just hit down, and it got a little bit off, so I'm just going to enter 5.5 again, and I get negative 1.359, negative 1.359. It doesn't really matter what number exactly it is. It does matter the sign. Both of these are negative, so the speed of the particle is increasing. So that's part of it. And then the true part is because the rationale, the reason for our answer is because both velocity and acceleration have same signs. And if you didn't say something about velocity and acceleration in your answer, then you did not get credit. You need to have both velocity and acceleration. For part B, find the average velocity. Average of anything is always going to be 1 over whatever interval, so 6 minus 0, 1 over 6 minus 0, integral of 0 to 6 of velocity. So this is going to be, my 6 was not that great, still not that great, a little bit better, of velocity. So Vt dt. And this is something that you have to know. Average of anything is this format. When we plug this into the calculator, what do we get? So again, velocity is my y1 function, so it's going to be 1 divided by, wait, let's get at this, sorry. 1 divided by 6. We're going to multiply that by this integral, so math 9. Integral of velocity, so that's going to be vars right, enter, enter, of my y1 function with respect to x from 0 to 6. When I do that, I get 1.949. 1.949. And it doesn't ask for anything about units, so we're good. Alright, so let's go to part C. Total distance. So total distance, that's just another definition that you need to know. It's going to be the integral between 0 and 6 of velocity of time, the absolute value of velocity of time, dt. If you don't have the absolute value in your integrand, in this inner part of the integral, then you don't get the point there. And then the other point comes from actually getting that correctly. So let's figure out how to do that on our calculator. So it's going to be math 9, the integral, and it's going to be math, right, and absolute value, ABS is what we're looking for. The absolute value of vars right, enter, enter, the absolute value of y1. That's going to be with respect to x from 0 to 6. And it'll take a little bit longer to calculate. It always happens that way when you have absolute value. And let's see what we get. My gosh. There it is, okay. 12.573. 573. There it is. Okay, so, and now we have to answer this part D. For this interval, the particle changes direction exactly once. Find the position of the particle at that time. All right, so changes direction. what does that mean? That means somehow velocity is positive and then goes to a negative, or goes from negative to a positive. It's a relative extrema, is another way of thinking about change of direction. So if I come back to my graph, again, I should look at this. This is my y1 function, this one right here. So on my y1 function, where does it hit 0? Where does it go from a positive to a negative, or vice versa? And you can see around this point it goes from a positive to a negative. So that's where it changes direction, but that is only the velocity. So we're going to be able to find the time when it changes direction, but we won't be able to find the position. But that's the first step. So I'm going to go to trace to get the point roughly. I need to find roughly that point, so I'm going to go second, trace. I'm looking for a 0, so I hit 2. My left boundary, I'm just going to say 5. My right boundary, 6, and I don't know, 5.5. Any point in between there is 5. Is fine. I should get 5.19. Yep, okay, so there it is. So that's the time that we're looking for, and this is going to be the t, so 5.19. I'm just going to round it to 6. So that's the time where it changes direction. How do we find the position? The position is always going to be given by the integral of velocity. You go backwards from velocity. So it should be a start plus change type of deal. So that's my time, start. And I'm going to do plus change, and that will give us our answer. So what is our start? If I come back to this, I see that my start right here, at time equals 0, I have the position is 2. So my start is going to be 2, and my integral is going to start from 0. Those are what the values give me. And then I'm going to plug in this t, so 5.196, 5.196 for the upper bound, and again, taking the integral of velocity. And that will give us position. All right, so plug this in on our calculator. What do we get? So it's going to be, let's get out this. It's going to be 2 plus math 9, and it's going to be integral of, var is right, enter of my y1 function, my velocity function, with respect to x from 0 to 5.196. And I already included the 2 in there, so I don't have to do that at the very end. And my final answer is 14.135. All right. Yep, there it is. All right, on to number 2. So this is the last problem on the final that you get to use your calculator. Number 1 was the first, this is the second, and then from here on, no more calculators. We're talking about a pot of tea that's cooling, and it's cooling between 0 and 10. Great, great, great. Use the data to approximate the rate at time 3.5. So time 3.5 is going to be right there, in between 2 and 5. So we're just going to take the secant line between 2 and 5 and find the slope between those 2 points. So the way that you do that is you do 52 minus 60. All of that is going to be divided by 5 minus 2. And this is going to be, this is approximately h prime of 3.5. 3.5 is approximated, I ran out of room here, but I have technology, I can just move it over. Ooh, I don't want to grab this though, I just want to move this. Oh my god, whatever. This thing is approximately this. And then, so this is going to be a negative 8 on the top and a 3 on the bottom, and it's fine to leave it as a fraction. If you want to actually evaluate what that is, what is that going to be? It's going to be 2 2/3, so it's going to be negative 2.667 rounded to 3 decimal places. And do we need units? Nope, just need to show the computations. There it is. For B, using correct units, explain the meaning of this thing in context of the problem. So this part right here always means average. It's 1/10 integral between 0 and 10. So we know that it's going to be the average, and then average of whatever this thing is, average of temperature, and that's essentially the answer. Most people made the mistake of saying it's the average of the change in temperature. Really, you just look at what's inside this box, what's on the right-hand side of the integral. That is the units, that is the measurement that you're looking for in terms of the average. So we'll say that 1/10 of the integral between 0 and 10, capital H of t dt, means the average and it's temperature, so temperature in degrees Celsius from 0 to 10 minutes. 0 to 10 minutes. And we got the context of the problem is just the units that it's asking about. So that's the first part. Now it's asking to use a trapezoidal sum of the 4 subintervals indicated by our table to estimate. Okay, so trapezoidal means I'm looking for the distance between here and here, which is 2, and I'm taking the average of these two. Let's just find all the averages really quick. So this is going to be 63. If you don't know how to find average, just add them both, divide by 2. Average between here and here, well, the difference is 8. Half of 8 is 4, so add 4 to 52 and you get 56. Average here, well, you go up 8, so I have to go up 4 from this one. That's going to be 48. And between here and here, it's 43.5. 43.5, and then I need to multiply by the distance between these. So that's distance of 2, distance of 3, distance of 4, distance of 1. So it's going to be 2 times this, and so forth. So we're going to say that 1/10 of the integral of, from 0 to 10, of capital H of t dt is approximated, little squigglies here, is approximated by this interval, and it's approximated by, I'll still have the 1/10, don't forget that, and it's going to be 2 times 63 plus 3 times 56 plus 4 times 48 plus 1 times 43.5. 1 times 43.5. And as a general rule of thumb, you should have at least this much work. You shouldn't jump straight to 126, as the AP graders will have a little bit of trouble seeing what you're doing. In fact, this is already skipping enough steps because this work up here wasn't shown how I found the average. Most of the time the keys will show this. They'll say 66 plus 60, all that divided by 2, all of that times 2. So this part right here is just finding the average, and this is finding the distance between those. So you don't have to show that much work. This amount of work is fine, but make sure you're at least showing this amount of work on your test from here on out on any type of approximation, left hand, right hand sum, Riemann sum, or trapezoidal. All right, so this is where we just punch it into our calculator and we get our approximate. I have 1 divided by 10. It's going to be times all this stuff in parentheses, 2 times 63 plus, and you don't have to worry about order of operations in here because multiplication comes before addition, so no more parentheses aside from the very end. 3 times 56 plus 4 times 48 plus, and it's just 43.5. You don't have to do the 1 there. And we get 52.95. 52.95. Should box this one as well. Although both these are fine. Alright, on to part C. So we need to evaluate this thing. So the integral between 0 and 10 of h prime of t dt. This thing is going to turn into, okay, so we have an antiderivative of the derivative. This is fundamental theorem of calculus. They cancel each other out. I'm just left with h of t evaluated between 0 and 10. So that turns into h of 10 minus h of 0. Just plugging those in. What is h of 10? Just from the table, h of 10 is 43. So this is going to turn into 43 minus h of 0, which was 66. Minus 66. And math, so go up 4 to get to, go up 7 to get to 50. And then go up another 16. So 16 plus 7 is 23. Is that right? So this should be equal to negative 23, and this is a calculator problem. Let's just double check Mr. Sindel's math. 43 minus 66. All right, whew, good. I can still be a math teacher. All right, so it's negative 23, and I also need to, using correct units, explain what that meant. So this thing, integral between 0 and 10 of h prime of t dt. So what it means is I'm taking the antiderivative of h prime, which means I'm left with h. So my units here need to be in terms of h, just the degrees Celsius. This is very reminiscent of start plus change equals end. This thing is change. It's how much it changes from when? From 0 to 10. If I take the derivative or the antiderivative of the derivative, it usually talks about just change. So this thing means change in degrees Celsius from 0 to 10 minutes. Perfect. All right, and to part D, at time t equals 0, all this stuff happens. The temperature of the biscuits is going to be this thing. Okay, I'm already noticing that this function b prime of t has this negative in it, which means we don't have to worry about any subtraction. It already accounts for the fact that it's going down. And we need to figure out how much cooler. Okay, so this is a tricky question. Not only do we need to figure out what the new temperature is, but then we need to figure out how much cooler they are than the t. All right, so there's quite a few moving parts here. Let's first figure out what's going on here. Let's figure out what the biscuits are at time equals 10. This is a totally unrelated problem. This is biscuits, and then all of the stuff up above was t. So when we do this, we are going to do t at 10. We're going to do start plus change, and that will equal to our end. So our start, it tells us that it was removed from 100 degrees, or they start with a temperature of 100 degrees, and we're going to add this integral. It's not a subtracting because it's already including that negative, so it's going to be from 0, because at time equals 0, to time equals t, which is 10. And of this b prime of t, I'm lazy, so I'm just going to write b prime of t, because I have a calculator to do this work for me, and I will get the final temperature. Okay, so coming back over here, I need to do all of that math. So 100 plus math, hold on, go back, I saw that it's 100, not 10, plus math 9 of b prime t. Okay, time to enter all this stuff. Negative 13.84 times e to the power of negative 0.173, oops, forgot the 173 times x, or t in this case. Okay, perfect. That is our function. Great. Let's evaluate it with respect to x from 0 to 10. I already included the 100. I am ready to get my final answer of 34.183. 34.183. Okay, so keep in mind the context of the problem. This thing represents the temperature of the biscuits at time equals 10. Great, we found it. But now we need to answer the question, how much cooler are the biscuits than the t? Well, we found how much the t is at time equal 10. If I come back over here, the heat of the t at time equals 10 is 43. So my final answer, 43. The biscuits are cool. Yeah, so I'm doing this correctly. I was making sure I wasn't doing this backwards. Minus 34.183. And it is too late at night for me to be doing mental math, sorry. But we have the calculator here for a reason. 43 minus 34.183 and 8.817 is equal to 8.817. Just double checking that I wrote that down right. Yeah, 817 degrees Celsius cooler is our final answer that we're looking for. Do we need to box anything up here? I guess we could box this negative 23. It's kind of important. And change in degrees Celsius was important, I guess, too. Cool. And that's number 2. Cool. We are on to number 3. Okay, so we have these two functions. Okay, let's identify which one is which first. So this is f of x right here. Maybe I should write it down here. This is f of x. I know that because x cubed looks like this. And from there, I know that this other one is g of x, and that makes sense because sine starts from 0 and it goes in a sine wave like that. Perfect. We don't even need that for part A, but we need to find the line tangent. Okay, so line tangent, we're doing this y minus the y coordinate is equal to the slope times x minus the x coordinate. Fill in all this, and we have x equal to 1/2. 1 out of 3 done. What do we do with y? Okay, so let's find y first. So if I plug in 1/2 into f of x, so f of 1/2, that's going to equal 8 times 1/2 to the power of 3. 1/2 to the power of 3 is 1/8. So this is going to equal to 1. So that means our y coordinate is 1. All right, so far so good. Now we need to find this thing. This is the slope. So this is f prime at 1/2. I need to first find f prime of x, and then I'm going to plug in 1/2 into that. So f prime of x, that's going to be, I'm going to move down the 3, so that's going to be 24x squared, and now I need to plug in 1/2. So I'm kind of running into my b area, but hopefully it should be fine. F prime of 1/2, and this is going to equal 24 times 1/4. 1/4 is just 1/2 squared. 24 times 1/4, or 24 divided by 4, is 6. So the slope here is 6. Done. All right. Part B. Find the area of R. Okay, so area, you're just doing the top function minus the bottom function. Trouble here is we have no calculator. Okay, so let's go ahead and do this. We know that the area of R is going to be equal to the integral between 0 to the xn coordinate, which is 1/2. And we're going to be doing our top function g of x, and we might as well just write what that is because we don't have a calculator. Sine of pi x, all of that minus our f of x, which is 8x cubed. Okay, all of this is with respect to dx. All right, so how do we do this thing? Technically, you could separate this into two integrals, but since you're doing the same bounds, you might as well just keep it one integral to save time on writing. So what is the antiderivative of sine of pi x? Notice here, and this might be a little bit hard to see, we need taxman. Inner for this trig house is going to be pi x, so dinner is going to be pi. Dinner is not 1, so taxman is needed. And the quick taxman, I know that I need to just divide by pi. So antiderivative of sine of pi x. There's my 1 over pi. I'm paying the taxman. I'm kind of doing the work in my head, but you can see where I'm going with this. So anti-same means change. I'm going to change the sign, so it's going to be a negative 1 over pi cosine of pi x. That's the first antiderivative. Perfect. Second antiderivative. Let's not forget this minus sign and antiderivative. So this is going to be 8x, and it's going to go up a power to the power of 4, and then divide down by that 4, divided by 4. So it's really 2x to the power of 4. Perfect, and all of this thing is being evaluated between 0 and 1/2. 1/2. From there, do we need to worry about plugging in 0? Not there. We do, because it's a trig function. Trig function, you always want to plug it in. Anything e-house or trig function, always plug in that 0. It might be something. So first, let's plug in 1/2. So it's going to be negative 1 over pi of, okay, so it's going to be cosine of pi over 2. What is cosine of pi over 2? So I always like to draw this just in case we forget. Cosine of pi over 2 is right there. It's 90 degrees, and cosine is the x-coordinate. X-coordinate is 0, so it's going to be 0. And that's going to be minus, when I plug in 1/2 here, and I'm just going to write this in a different color so I can say work. This is really 2x to the power of 4 instead of 8 over 4x to the power of 4. All right, so if I plug in 1/2 into here, it's going to be 1/2 to the power of 4. 2 to the power of 4 is 16. Let me just double check that. 2, 2, 2, 2. 2 times 2 is 4. 4 and 4 is 16. Perfect. So it's going to be 1/16. So 2/16 is 1/8. I did a lot of mental math there, but hopefully you can follow what I said in terms of just verbalizing it. Okay, so that was what happened when we plugged in 1/2. Now we need to subtract what happens when we plug in 0. All right, so we have this negative 1 over pi. Cosine of pi times 0 is cosine of 0. Cosine of 0 is right there. The x-coordinate is 1 on the unit circle, so this is going to be times 1. And then I'm going to subtract what happens when I plug in 0 there. I just get 0. All right, this simplifies. That was all 0, so don't worry about it. That was all 0, don't worry about it. I have a negative 1/8, and I have a negative, so it's a positive 1 over pi, so plus 1 over pi. And there is our final area between g of x and f of x, that area of R. All right, in part C, write but do not evaluate. Yes, okay, so those are the easy ones. Integral expression for the volume. Most people got this one correct. When R is rotated around the horizontal line, so volume. Our volume, V, is equal to, if you forgot the pi, I think there's one person that forgot the pi, it's going to be an integral between, same values, 0 and 1/2, and then it's going to be rotated around y equals 1. So y equals 1 is right there, so what is the, oh, I could have done a better line. Ooh, that's better. The outer function is now f of x, so that's going to be my first one. So it's going to be f of x, and do I need f? I'm just going to write f of x. I'm going to be lazy about this. F of x minus 1 that thing is going to be squared. Is that right? Because I'm thinking about this, if I was rotating, then I have this shape, so it's going to be bigger circle minus inner circle, so yes, it's going to be squared. And then I'm going to do minus the other circle, which is going to be g of x minus 1, all of that quantity squared, and then I need all of that times d of x. And we're done. All right, we're on to number 4. So we have one of these guys. Okay, so we need to find g of negative 3. So let's start off. G of negative 3. So that's going to be, it's equal to 2x. It's a little bit hard to see on mine. So it's going to be 2 times negative 3 plus the integral between 0 and the x becomes negative 3 of f of t dt. And it should be noted that this thing is f of t. Alright, so evaluating this, simplifying this actually a little bit further, that's going to be turned into negative 6 plus, oh, actually I'm going to switch this to a minus and then switch these bounds from negative 3 to 0, so it goes from smallest to biggest of f of t dt, and I need to find what that is. That's just the area bounded by this region. So from negative 3 to 0, so negative 1, 2, 3, so from here to here. So it's asking about that quarter circle. All right, so again, area of the circle is equal to pi r squared. So the radius here is 3, so 3 squared is 9, 9 times pi. This is 9 pi, but it's only 1/4 of it, so 9 pi over 4. So this is negative 6 minus 9 pi over 4. And that's as simple as I can get it. I mean, I could maybe combine fractions if I got the denominator the same, but I think that's as far as we need to go. So that's g of negative 3. Let's find g prime of x. Bless you. G prime of x. So you just take the derivative of each of these individually. So g prime of x is equal to, bless you, g prime, that means I'm taking the derivative of 2x, which is just 2, and derivative of this thing, and that's using the fundamental theorem of calculus, which means that x is going to be plugged into the t, and it's just f of x. So 2 plus f of x. And that means g prime, when I plug in negative 3, and that's pretty straightforward, is equal to 2 plus f of negative 3, and that's the height at negative 3. So where's negative 3? So 1, 2, 3. The height at negative 3 is 3. So is that right? No, sorry, I was going positive 3. Sorry. When I go to negative 3, 1, 2, 3. There we go. Okay, the height is 0. So this is going to be equal, or this is going to be turned into 2 plus 0, which is just equal to 2. And I should box this one as well because that's an answer. And on to number B. We're looking for an absolute max on the interval. So obviously we need to check the endpoints, negative 4 and 3, but we also need to check the critical value. So finding that critical value can be a little bit difficult. Most people would assume, oh, the critical value is where it goes through the zeros. You're almost correct, except for the fact that we have this additional 2x to worry about. So what we really need to do is just say, deal with g prime. G prime of x, that needs to be set equal to 0. But we already found g prime of x. G prime of x was the same thing we found in part A. G prime of x is 2 plus f of x. So 2 plus f of x needs to be set equal to 0, which is the same thing as saying f of x needs to be set equal to negative 2. F of x equals negative 2. Where does that happen? Where does that intersect our graph? If we come back over here, f of x equal negative 2, that would have been a line like this, roughly. It intersects our graph right there, and that is, you can probably remember this from a previous problem. This is exactly 2.5. How do you verify that it's 2.5? This is how. I can find the equation of this line. This line is y equals, well, the y-intercept is 3, so something plus 3, and then something x plus 3. What's the slope? Well, I go down 1, 2, 3, 4, 5, 6, and the right 1, 2, 3. So down 6 over 3 is the same thing as a slope of negative 2. Where does this have a height of 2? Where is the y value 2? That's equal to negative 2x plus 3, and then subtract 3 from both sides. Oh, sorry, negative 2, not positive 2. Subtract 3 from both sides, we get negative 5 is equal to negative 2x. Divide both sides by negative 2, you get x equals to 2.5. Perfect. We have verified it is indeed 2.5 for the critical value. So we have our start point, end point, so let's do our table. Table is going to have a negative 4, it's going to have our 2.5, and we're going to have our 3. Okay, we need our start, we need our plus change, and that part's going to be the difficult part, and that's going to equal our end. All right, so our start, I don't know if they never really gave us a start in this problem, so the start's just going to be 0 for all of these. That's fine. Okay, the change, this guy's going to be fun. So it's going to be the integral between 0, this is always going to be plus also, plus, 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 integral between 0 and -4, so obviously we're going to want to switch those, of g prime of x. This thing is going to be yucky, but we'll deal with it in time. So it's going to be integral between 0 and 2.5 of g prime of x, and it's going to be the integral between 0 and 3 of g prime of x. All right, what is g prime of x? Again, it's the same thing that we found in the previous problem. It's 2 plus f of x. So I just want to analyze this problem. Actually, I can do it right here. So this is going to turn into minus the integral between -4 and 0. And then there's two parts here. There's going to be, I guess I can just write this out a little bit, 2, and then I'm also going to subtract the integral between -4 and 0 of f of x. So I broke this up already because this is g prime of x. There are two parts. I know that one of them is going to be the derivative of a constant, and one of them is going to be the derivative of f of x. And both of these should have a dx in there if I'm being formal, but you're not going to lose points if you don't put those. All right, so this thing is pretty straightforward. Between -4 and 0, that's a distance of 4. 4 times 2, this thing is going to be 8. And I'll do that in a different color. This thing is going to be a little bit difficult. Well, not difficult, it's just you need to go back to the graph. So from -4 to 0 of f of x, what does that look like? Between -4 and 0, it's all of this stuff. I need to add them up. So this is a quarter circle. If it was a normal circle, it would have a radius of 1, so pi r squared would just be pi times 1. So this is pi over 4. So, and it's actually a negative pi over 4 because it's below. So adding both these up, 9 pi over 4 minus pi over 4 is 8 pi over 4. And then 8 pi over 4 is just 2 pi. So I come back over here. This thing is 2 pi. All right. Now let's move to the second integral. So this thing is going to be the integral from 0 to 2.5 of the 2. And then I'm also going to have the integral between 0 and 2.5 of f of x. Again, in red, I can do what the numbers are up above. So 2.5 minus 0 is 2.5. 2.5 times 2 is 5. That thing is 5. This whole integral evaluates 5. And then 0 to 2.5 of f of x, again, refer back to the problem. 0 to 2.5, so I have to do this area of the triangle and this area of the triangle, add those up. This one is going to be negative, keep that in mind. All right, so I have a distance of 1.5 here, 1.5, and a height of 3. 3 times 1.5 is 4.5. Okay, let's not do decimals. I'm getting all messed up. Let's just do fractions. This is really 3 halves. This is really 3. So, and then I'm going to have to take half of it because it's a triangle. So it's really 3 halves times 3 halves. So it's 3 halves squared. This is 9/4. Hopefully I got that right. I remember messing that up in a previous problem. And then over here, this is going to be a distance of 1 because it goes from 1.5 to 2.5. So a distance of 1, and this is by 2. So this is -1 right there. So I have 9/4 minus 1, so minus 4 over 4, and that's 5 over 4. So come back here. This thing evaluates as 5/4. Whew, lots of mental math. Here we go. And finally, this is going to be integral between 0 and 3 of 2 plus integral between 0 and 3 of f of x. Okay, again, 0 to 3, that's 3 times 2, which is 6. And again, just to back up to make sure we know what the heck we're doing here, we're looking for the biggest number. Whichever one of these is biggest wins. From 0 to 3 of f of x, again, coming back to the graph, 0 to 3, so 0 to 3. This is a little bit easier to calculate because this is 1.5, this is 1.5. These two triangles are equal, therefore they cancel each other out. The area is 0, so this thing is 0. All right, which one of these won? Let's move this to the other side. This is going to be, this is a huge negative number, so not even close. This is a -8. This is equal to -8 minus 2 pi, so definitely not that one. This one is going to be equal to 5 plus 5/4. Let's just get common denominator, so this is really going to be 20 over 4, 20 over 4, which is the same thing as 5, and 5 over 4, so this is 25 over 4, and this thing is equal to 6. 25 over 4, well, 24 over 4 is 6, so it's 6.25, and that's bigger than this. Whew, lots of work. We found that this is the absolute maximum. So, in conclusion, the absolute maximum is 25 over 4 at x equals 2.5. And now on to part C. So we're looking for a point of inflection, IP. So start with our definition of IP. IP is where, and it's G, so not F, it's G double prime is sign change. Sign change. All right, well, what is G double prime? So coming all the way back over here, well, G prime is 2 plus f of x. So if I take the derivative of both of those terms to do this next derivative, that goes to 0. It's derivative of a constant, and that's now f prime of x. So this thing, go away. This thing is G double prime of x is equal to f prime of x. And that needs a sign change. So f prime of x, we're given a graph of f, so sign change of f prime is a slope change. So we're looking for a change in slope. So positive, positive, infinite, but it's still from a positive to a positive. So it doesn't count positive, positive, oh, all of a sudden negative, negative, and all negative. So right there, there's a slope change. So G double prime x sign change. Okay, whoa, what happened there with my at symbol? At x equals 0. That's all you really need to say. You need to say that it's a sign change with G double prime, and then, of course, the x coordinate. All right, part D. So first we need to find the average rate between -4 and 3. So average rate is going to be this line here. What is the slope of that line? So to find the slope, you see the change in y's, change in x's. So it's going to be -3 minus -1. So coming back over here, -3 minus -1. All of this divided by the x coordinates, which are 3 minus -4. 3 minus -4. So that's equal to, this is -3 plus 1, which is -2, over negative kiss is positive, so it's 7. -2/7 is the average rate. Perfect. It says that there's no point C for which f prime of C is equal to this -2/7. Explain why this does not contradict the mean value theorem. So normally, if you have a continuous and differentiable function, you should be able to find this slope somewhere on this graph. And you'll notice that this slope is definitely nowhere where it's positive, and it all of a sudden just shifts to this giant negative slope. This average rate is never found in this graph. And obviously you might be thinking, well, it should happen right there, but we had a sharp corner. And that's really the answer. We had a sharp corner, we had a point that was not differentiable, and therefore that it made the mean value theorem not hold true. You can't even apply the mean value theorem. And by the way, this is not the only point that's not differentiable. This point right here is not differentiable. Why is that? Because it is an infinite slope. It is a vertical tangent. All right, so we want to say in words, this does not contradict mean value theorem because, oh, cannot spell there. There are 2 points, or you can just say points. You don't even have to say that there's 2. There are points in that interval in -4 to 3 that are not differentiable. I'm just going to abbreviate like that. All right, time to go to the most missed question on the final, number 5. All right, so let's deal with this first one, the line tangent to the graph of W. All right, so this is going to be a y minus the y, and actually I know what's going to be, so I'm going to make this a little bit bigger. Y minus the y function is going to be equal to the slope times x minus the x coordinate. All right, so this is a graph of W. So I need to figure out what my y function is. Y function, or the y value here, is going to be how much waste I started with, the y value of the waste. And it tells us that it starts at 1,400. So this is really 1,400 here, and this at time equals 0. Okay, how do I find this value here? I'm really saying dw dt when I plug in 0. But that's a little bit unclear because I can't plug in 0 for w. I mean, I can't just say 0 minus 300. That doesn't make any sense because w is a function where you start off with 1,400. So what this is really saying is I plug in 1,400 because that is w of 0. So you can actually say w of 0 should be 1,400, which means this thing is going to be, let's write this down here, dw dt is going to equal 1/25 of that 1,400 minus 300. And that's going to be negative 1,100, and if I simplify that all down, I get negative 44. So I don't know why I did a negative, but it should just be a positive 44. So that's our slope, 44. So that part was pretty hard to get to this point. And then once you get there, you should be able to find what happens when you plug in t equals 1/4. So if I do that, I want to simplify this equation a little bit more. So this equation is going to turn into y is equal to 44x plus 1,400. It's a little bit easier to see this way. And when I plug in t equals 1/4, y is equal to 44 times 1/4 plus 1,400. 1/4 of 44 is 11, so 11 plus 1,400 is 1,411. Cool, and then we needed units, we did not. So we have our equation, that was the hard part, and then using our equation to find 1,411. All right, another almost equally hard part is finding the second derivative. And then we have to find if it's an underestimate or an overestimate at time equals 1/4. Okay, so second derivative. The tricky part about the second derivative of this function is it's with respect to t, not with w. If it was with respect to w, you'd just be done. It's 1/25, right? But since it's with respect to t, I think the best way to think about this is kind of thinking of it as a y minus 300. So you would really be doing 1/25 times y prime. That's essentially what would happen because this boils down just to y prime times the constant of 1/25. But it's not y, it's w, it's w prime. So I'm going to say that d squared w over dt squared, this is going to be equal to 1/25, that's just the constant, the same number out there, and then times the derivative of the inside, which is just w prime. And I could be lazy and write w prime, but I should just stick with the form that they gave us. Instead of saying w prime, they say dw dt, dw over dt. And we know what that is. dw dt is already given to us, so that's going to be 1/25 times 1/25 times w minus 300. And if I want to simplify that a little bit, I can say that's equal to 1 over, is that 625? Maybe you shouldn't simplify it, but I think it is 25 squared. It is 625 times w minus 300. All right, so now we need to figure out if it's the overestimate or underestimate from this answer. And it's pretty clear to see that this function is purely increasing it ever since you get to 300. It is purely increasing. So that means that d squared w over dt squared, this thing is always going to be greater than 0 since this is our increasing function whenever w is bigger than 300, which happens to be the case here. I mean, w is 1,400. It's definitely a little bit bigger than 300. I can say if this. So if it's concave, this means it's concave up. So graphically what is happening, we have something that's concave up, but we graph something that was out here. So it should be up there, but it was down there. That means it's an underestimate. This implies underestimate. And then on to part C. So this is the beefy part of the problem. This was out of 5 points. We're finding a particular solution. So it gives us this. Every time you see particular solution, you know that you should be doing steps 1 through 3, separate, integrate, and evaluate. But you don't actually have to do the fourth step, isolate. I will be doing it in this video just because I'm I want to have some fun, I guess, and maybe you want to learn how to actually solve it. That one last point isn't really worth it. I would recommend just going up to step 3. So what is step 1? Step 1 is to separate. Separate. So we had this equation. I'm going to cross multiply, and this w minus 300 needs to go with the w, so I'm going to divide both sides by w minus 300 so it goes on this bottom part, which means I am left with dw is divided by w minus 300, and that's going to be equal to 1/25 times dt. Perfect. Now we need to do step 2, integrate. And okay, I'm realizing I should have just put this underneath step 1 because I need a lot of room. So step 2 is integrate. Integrate, try that again. If I do that, I'm left with integral of 1 over w minus 300. I'm just writing it in a slightly different form. That was kind of messy. W minus 300 d capital W is equal to integral of 1/25 dt. So I need to actually find the antiderivative, and antiderivative of 1 over anything is going to be the natural log of that anything. So it's going to be natural log of absolute value w minus 300 and absolute value. And that's going to be equal to 1/25 times just t, and don't forget our plus c. All right, that was our integration. And now if you just evaluated, if you plugged in 0 for your t, and if you got 1,400 for your w, you get basically all the points. You get 4 out of 5 points. That would be step 3, evaluate. Do I want to evaluate for this problem, or do I want to do any tricky things? I think I can just evaluate for this problem, so I'm going to go over here to step 3, evaluate. Because I see that if I plug in 0 for t, this thing is going to cancel out really nicely. Sometimes we have to deal with this, but it comes out okay in this case. So the natural log of absolute value of w is now 1,400 minus 300 is going to be equal to 1/25 times 0 plus c. When I do that, this is going to be the natural log of 1,100. Absolute value is equal to c. Perfect, we found our c is. Sometimes that's really hard to do. And I guess that's kind of isolating at this point. That was kind of step 4 also. But now we need to actually find what that differential equation is. So to do that, we found our c. We need to come back here and okay, so that was not step 4, sorry. Step 4 is actually getting w by itself, which is a little bit difficult. So step 4 is isolate. And in that case, we want to, the whole goal here is get this w by itself. How do we do that? Well, we have to get rid of the natural log of both sides. So we have to take both sides to the power of e. When we do that, the natural log will cancel out, of course, and we're left with w minus 300 is equal to e to the power of all of this. And remember, c isn't c anymore. C is natural log of 1,100. So it's going to be e to the power of 1/25 t plus natural log of 1,100. All right, this thing can be simplified a little bit. So I'll have w minus 300 is going to be equal to e to the 1/25 t times e to the natural log of 1,100. And I'm just going to kind of skip a step. I'm going to say e to the natural log of 1,100 is just times 1,100. So let's back up here. This is just times 1,100. And I'm left with w is equal to now 1,100 e to the 1/25 t plus 300, and there's our final answer. And finally, our last problem, number 6. This one was pretty hard as well, although not nearly as hard as number 5. So we have this function, and we need to find g prime of 0. So let's first start by finding g prime of x. And then we'll plug in 0 once we find that. So g prime of x, that means I'm taking the derivative of both of those. So when I take the derivative of e to the ax, you should know the derivative of e house. You multiply e to the power of ax, that stays the same. And then, so that's daughter. And then dinner, this is the inner. Derivative of the inner is a times x. So derivative is just a. So I need to multiply by a. And that's going to be plus the derivative of f of x, which is just f prime of x. Cool, cool. What happens when I plug in, so let's say g prime of, we're plugging in 0. When I plug in 0 for all the x's, that's going to be a e to the power of 0 plus f prime of 0. Ae to the 0 is just a, so this is going to be turned into a plus f prime of 0. It tells us that's negative 4. Or I guess it's really just a minus 4. Alright, g double prime of x. Alright, so kind of the same rule. We're taking the derivative of this, and you can see that another a is going to come down because this is still a constant a, it's not a variable. So we're going to be left with a squared e to the ax plus f double prime of x, and g double prime, when we plug in 0, is going to be equal to a squared e to the power of 0 plus f double prime of 0, and that's going to turn into just a squared, and then f double prime is 3, so a squared plus 3. And then to b, so we have this function h, and k is a constant, so it's not a variable. We need to find h prime of x, and then do some other stuff. Okay, so let's first start by h prime of x. How do we find that? Well, we have two functions. We have a cosine and an f of x. This is a product rule, so it's going to be 1 and 2. So our product rule again is 1d2 plus 2d1. So 1 is cosine of k of x times d2, which is just f prime of x, f prime of x. And that's all going to be added to 2, which is f of x, times d1. So derivative of cosine. So change means change the sign, so I'm going to do a negative out front here, and it's going to turn into a sine of k of x. So that's dinner is times k. Alright, and so that is h prime of x. I guess I could have simplified it a little bit further, but that is good enough for now. And write an equation for the line tangent to the graph of h at x equals 0. Okay, line tangent, that means we're doing y minus the y coordinate is equal to the slope times x minus the x coordinate. Alright, the x coordinate, it tells us, is 0. Alright, so we can find what the y coordinate is by plugging in 0 into our h function. So what is h of 0? Because that'll give us this thing up here. H of 0 is going to be cosine of 0 times k, which is 0. Cosine of 0 is 1. And if you don't know why that is, that's the angle 0, and it's the x-coordinate because it's cosine, so it's 1. So it's going to be 1 times, and x is 0, so it's going to be f of 0. F of 0, it tells us up here, is times 2, so that's equal to 2. Perfect. Okay, this box right here is going to be h prime of 0. And we found h prime, so now we're going to actually use it. Plug in 0 and find what that evaluates to. And that's going to go into that box right there. So cosine of 0, we already know that from back here, that's just 1. So it's 1 times f prime of 0. F prime of 0 is negative 4. And then I need to subtract f of x, so f of 0, which is 2, and times sine of 0. Sine of 0 is right, sorry, it's not right there. Sine of 0 is still right there, but it's the y-coordinate. Y-coordinate is 0 times k. So all of that goes away to 0. So it's just 1 times negative 4, which is equal to negative 4. So the slope is negative 4. And that is the answer. I mean, you can simplify it if you want, but you don't have to. You can simplify it to y equals negative 4x plus 2.